Are we waiting for more people?
I think so. Yeah.
Right. I assume, are you recording it? And I'll just share my screen. Cool.
Oh, can you share your screen?
Yeah, should be able to. Oh yeah, I can choose what I want to share.
All right. Oh, something that is helpful. If you click the share screen button, click the top left where it says screen. You know what I mean?
Okay.
Yeah, because that shares like your entire thing, so then you can switch windows and still share the same.
Oh, should I just do the whole screen?
Yeah.
So,
Yeah.
sure. This works. Oh. So, do you want to start now, or should we wait for more people?
Yeah, sure. We can just start.
Okay, so now we're gonna actually start like working on Autodesk and just like actually using all the parts, and I'm just gonna start making the parts for the original bike stand that you saw in the video and going through and explaining how to use all the tools that they have in their ribbon and slowly getting more advanced, so different ways you can do sketches and things like that. And also, as a disclaimer, there are obviously multiple ways you can usually CAD most things because there are a lot of different tools that you can use. And so sometimes when parts get more advanced, there are a lot of different things you can do to get to those parts. So just because I do it a certain way doesn't mean if you do it differently, it's necessarily the wrong way, I guess. So yeah. And so first you just want to click new and start, or you can click here. There's all. Oh my God, I don't know if my computer can handle this. Okay, so standard is just like a regular part. There are usually two kinds of parts, which is metal, which you also saw there for a second, and standard. And sheet metal has some different properties that I think Jonathan will show you later when he makes one of the brackets for the bike stand later. And so, yeah. Okay, so first I'm just going to make the base brackets for the bike stand. Jonathan, do you want me to bother making the holes for now, like within each of the pieces, or should I leave you to do that?
You can just use the whole tool.
Okay.
You can just do that. Yeah.
So The brackets he had, and although in his bike stand he had circular tubing, we're just going to use square tubing for the actuating hole. And although that may not make sense right now, I'm sure it'll be fine later. You'll see. And so most of his parts were just square steel tubing. And so you can use this as a rectangle. So first what I did is I made a sketch. Actually, let me just go back so you guys can actually see that. Sorry, I'm like working really fast. And so when you open up a part, you're gonna have this whole menu and all these different things that you can do. And it starts in this section called 3D modeling. And when you click these, there's like the different sections up here in the ribbon. And so it'll say in this base section of 3D modeling, which is where you draw 3D modeling. And because you have nothing here yet, you want to just click start 2D sketch, or you just click this thing. And then it'll give you a set of planes that you want to start your sketch on. Usually when you're just making parts, at least right now, it doesn't matter that much which plane you choose. It's kind of just preference to me. But so I'll just click this plane. And so now I'm making a 2D sketch in this plane of what I will be making. And so to make the tube, typically what you would want to do is you need to get this square tool and you can just make a square. As you can see, it showed a dimension there, but it doesn't matter right now, or you can input it, but yeah. And so everything that we do is in inches. You can change the dimensions of it if you need to make something in centimeters or millimeters or whatever dimension you need to do. But most of the stuff that we're going to be doing in FRC is all just going to be in inches, especially because that's how all the game parameters are made. That's how FRC communicates all their games to us. So it's just easier to make all our parts that way. And because most of the parts we use are measured in inches. So first parts we're going to make is just going to be a 1x1 tube. And similar to a lot of the parts we do use in FRC, it's just going to be like a 1x1 channel of tube. So there are a lot of different ways you can make the inner tube for this. I'm going to show you a fancier way right now. And so one of the things you can do in sketches is there's this offset tool, which to me is really helpful, especially for stuff like this, is as you can see, like whenever you hover over any tool in Autodesk, it'll give you this little pop-up that kind of shows and gives a brief explanation of sort of what's happening and like what the tool is going to do. So as you can see by this, it's going to like take any lines that you have and like whatever completed line body that you click on, and it's going to make sort of like, I just kind of hard to explain, but like a kind of a copy of that and a different scale. So if I click offset, as you can see, it's selecting that whole square, and then I can just go down a little bit. And I would say the reason I'm doing it this way is because, so I made the outer edge, and then using an offset allows me to think, okay, how thick is this tube going to be? And so I would say just for now, I'm just going to do like a 0.1 inch tube, a good just base, like all the parts that we use. And so now I clicked finish 2D sketch, that finishes the sketch, and now I've made the sketch, and it took me back to this oriented plane over here. And so now, and this is also a useful tool, it's just the cube. I mean, I don't really know what you want to call it, but it basically just shows you what orientation you're in inside of CAD. And so right now, this is I would like top from right view. And so now with this 2D sketch, you can do a lot of things to it. There are a lot of these different tools that you can use, but one of the base tools that you're going to use just in CAD after you make a sketch is just extrude it. And so this takes a 2D sketch of plane that you made, and you need to figure out which part you want to make and whatever it highlights. So here I found the highlight of exactly what I want to be extruded. So I'm going to click that, and then it'll give me this menu on this side. I have to move this. I'll like make this a smaller thing. Oh gosh, I'm just going to do this. And so now it already shows me that it's usually just going to give you some base distance of 1 inch that it's extruding, but it's basically just taking that 2D plane or sketch that you made and bringing it into a 3-dimensional plane. So I'm just going to do 10 inches for our bike stand. And these dimensions can be modified later if we wanted to, but I'm just going to choose 10 inches for now to make that. Okay, and so now this is going to be our base tube for the bike stand. And so I guess to make this easier later, right now, I mean, obviously some people might do this differently, but so like when we're making this, although it's the same tube that we're going to have to use, well, actually, Jonathan, do you want to make the holes inside the assembly, or do you want to make separate tubes at the base?
I just use separate tubes, make it more
Okay.
fancy.
Okay, sure. So basically, so like even though each tube that we're going to use in at the base is going to be sort of like the same looking part, when we assemble everything and when we make it so that you can have screws in it or bolts in it or like screws into it and brackets on it, they're going to have different holes in different places because not everything is going to be the same, and this isn't really a symmetrical um, assembly. So I'm gonna have to make different tubes for each different what are they called? Like part or like yeah, part of the bike assembly so that we can have separate holes in them once we end up making the actual assembly. So I'm just gonna do that by actually I have to save this first. So obviously you want to save often in CAD because like especially once you get to like super big assemblies, it's going to start taking a lot of processing power. And if you accidentally do something that like gets close to breaking things or like kind of like breaking the sketch, you can do something that'll just make CAD crash. And then if you haven't saved CAD, then you're just going to lose all the progress you just had. So you want to make sure to save often, especially anytime you start like doing anything big inside your assembly. So, okay, this is version 1. So I just made one, high cost bike stand 1, and we'll get into, I mean, do you want to talk about like saving stuff now for FRC or should I wait?
Oh, you mean like GrabCAD?
Yeah, like,
No. We can.
okay. So yeah, I'm sure Jonathan will explain our save methods later, but for now, I'm just gonna save this in this folder and I'm gonna call it, I don't know. This will be the middle piece, bottom, middle, I don't even know. Where to? It's like, that's a terrible name. But okay, and so to make this easier, so what you can do in CAD is you have to be careful when you do this because especially when you put parts inside of assemblies, you really have to avoid making sure you don't name anything the same thing that already exists because whenever you have an assembly, it basically is like taking the constraint, so to speak, and it's referencing another part that already exists. And if there are two parts that have the same name, then CAD doesn't know which one to actually put in your assembly. So you have to make sure all your namings are correct, and when you copy pieces, you got to make sure you change those names. And so what I'm going to do is I'm just going to take this to copy it. I'm just going to paste it twice. I'm going to need 2 because on the bike, if you need to, you can look at the bike stand video. I've looked at it enough and got it enough that I don't need to look at it. But right now, it might be nice for people to have that up and just an image of it so they can kind of see what I'm talking about.
How can we find the bike CAD video?
It should be on the PDF that Jonathan sent in the chat. Jonathan, you should try to send that again, that link.
Well, you can just like open it. You can just like open the final thing that you made so that they see like exactly what you're doing.
Oh, you mean like show like the final one that I made?
Yeah, show the final one so they know.
Oh, okay, sure, yeah. So I'm gonna real quickly show you. So me and Jonathan before this, we just went ahead and CAD it. So like to make sure we're on the same page and know what's happening. And so I'm gonna show you sort of a finished product of what I did. Yeah. Obviously, there are going to be some things that are going to be different about mine because we kind of like fuse ideas for me and Jonathan's. But is also what is nice about CADing like as a group because like both people also can just like even though you're also both kind of the same thing, it can help to have 2 people thinking about the same thing because you can kind of fuse ideas and find the best result. If that makes sense. And so obviously my scaling is kind of weird, but this is sort of the main assembly of what's going to look like, except this middle piece is where we decided to just make that a square for a few reasons that I'll explain later once I get to it. And so as you can see, tabletop, it looks kind of weird, like it gets kind of glitchy when you try to like move parts around, but it works decently well. Mine's really shiny. And so when you bring this down, it like pulls up the stand so that if anything's on it, it goes on here and then it goes down here. obviously this wouldn't happen like that. Because like there's weird stuff about like going through the pieces, but obviously things like that will not happen in real life. Oh my gosh. Okay, how do I do that? Okay, there we go. Okay, and so yeah, this is the final assembly of what the bike stand should end up looking like in the end, or something close to it looking like after we finish all the CAD. And it'll have, so when you, I'm just gonna explain now that like whenever you do CAD, and especially us in FRC, we always, we have to make sure that we include all, like almost any brackets that we're going to use in all the pieces and make holes for all of our bolts and screws and things like that. Although it's not always necessary to actually CAD in the bolts, sometimes you want to do it to make sure everything will fit right, because bolts and screws do take up actual space like on your robot. And so even though it may seem like it'll work in CAD, you have to make sure and think about whether or not things will collide or if you'll be able to actually manufacture that piece, if that makes any sense. And so for example, right here, where you have a lot of brackets in the way, you have to make sure you're able to actually put that stuff down and actually put screws in those in all the holes so that doesn't collide with any other pieces. And so we always try to include brackets to make sure everything fits together perfectly and is also structurally sound. So this is going to be the final product. And so right now I'm making these tubes right here at the base. And so, and later on, and the reason I made separate tubes is so that, as you can see, there's going to have to be brackets here that we're going to have to make holes in. So each tube is going to have a different set of holes that allow the parts to sort of fit together, if that makes any sense. Okay, I'll leave that open for now. So this is going to be the base part that I'm going to use. If you want, Jonathan, what should we make the part? Oh gosh, I just clicked the wrong thing. But yeah, should I use the, should I bother like choosing materials yet, or should I?
Yeah, sure. So,
Okay, yeah, you can explain if you want.
All right, I'll explain it while you're looking for it. So basically, Autodesk Inventor lets you pick whichever materials you want to use, and although it doesn't like help your CAD like work better, it makes it look really cool. So
Yeah.
Jacob's making it cast steel right now, which yeah, it's shiny. So
Yeah.
if like it's a huge difference between the finished product of having it a normal just plain gray and then the shiny. You know what I mean?
Yeah. And so how you do that is you just go over here. This is the material area. It'll usually just say generic if you haven't chosen anything. Sometimes if you download parts off of the internet from some provider, it'll already have it in some kind of material, but usually it'll just be generic. You click this thing and it gives you this whole menu, parts in alphabetical order, and then you just find whatever material you want to make it and you choose it. And although Jonathan did say that it does make it look better, which I definitely agree with, also, so like when we're making a robot, especially, which we might try to do this year, is if you like define the material of all the parts, Autodesk is smart enough to actually figure out like how much that part will weigh on your robot, or well, it's an estimate, but it's smart enough to estimate. If you figure out the weight of all the parts, it'll like calculate how much the entire assembly weighs. And so that's also another reason it's useful to define the material parts, because then you can figure out how much that part would actually weigh, because especially in FRC, the weight does matter a lot. And so yeah, then I'm just going to save that again, and so yeah, I have to uncopy these, well, uncopy, just delete them, and then I'm going to copy them again so that it has that change material, and then, and so here, I'll just open this one. And so this is the second one, the second part that I'm going to make. And the reason as I said, the reason I made these is to have separate. But I guess for now, I'll put them in an assembly. And then, Jonathan, do you want to do the brackets? Like, are you going to do the brackets tomorrow?
Yeah, I'll do that.
Okay. So
like,
for now, I'll leave the holes out so that once you make the brackets, you can make sure everything lines up well. But yeah, so I need to rename these. And so this one, I guess we can make bottom, front square tube, and then I'll just make this the back one. Oh my gosh. Okay. And now, let's see. And so I made all these bottom tubes, Jonathan will go back in and put all the brackets in later. And so now I'm going to go ahead and assemble these, and then I'll make these actuating tubes that we're going to have here. Obviously, they're going to be square and not circular. Obviously, if you guys like have any questions, or if I'm going too fast, or there's anything I do that like you don't understand, then let me know. And so to create an assembly, you can go to new, just click new, and just standard assembly. That's the one we use all the time. And then you have this different menu pop up. It's not the same as what comes up with parts, although it has some of the same stuff. Like here you have 3D model, design, sketch, and all that same stuff. There's one extra part called assemble. And this is what allows you to sort of put in all these different parts and put them together. If that makes sense. So place is just will pick up, basically go to like the library of all the parts that you have. Well, really you're using a computer, and then you go to the parts that you want to find from there. Oh my gosh. And then here are the parts I want to place in. So I'm going to open that, and then you'll get this sort of menu right here. And then, so now it has this axis that shows you the axis of the part itself. And now I'm moving it around to sort of place into the sketch. It doesn't actually matter as much because later you're going to want to constrain things together. Oh, John, we didn't even go through the PowerPoint. Should I do that now, or?
That's fine. We can just, well,
okay.
We can just do that tomorrow. Like as you're.
Yeah. So yeah, tomorrow Jonathan's going to go through a PowerPoint to review everything that we did today. And so this I'm just going to place in the part. And now is an important thing you have to do. And although it's kind of a small thing, it can, like, if you don't do this, eventually it can really mess up your sketches. And so what you're going to do is, like, you don't want to just do this to any part, but you want to make sure the part that you choose is like a base part of the robot. And for it is to right click on the part and go down here to grounded. And you want to check grounded. And you can see the part that's grounded has this little pin right here. So it's kind of grounded in the sketch. And basically what that does is within the sort of like, I guess like world-ish of Autodesk, it makes sure that this part will never move relative to the Autodesk axis, if that makes any sense. Because sometimes when you're constraining parts together, putting things together, it'll like move around if you don't do this. And although you may not see it different at first, it can start to like make things go in crazy directions, and it's just not good. So you always want to find a base part of your robot that you know will probably never like be deleted or something, or that like you'll forget about it, and you just want to ground that. And so I'm going to place in the front one over here, and then, oh my gosh, and the back one. And so now, obviously, you can just like, oh, put it together, but no, you have to actually do this thing called constraining it. And so what this does is this is the main tool in Autodesk that you're used to sort of put everything together. And like, as it's called, it basically just constrains all the parts so that you can't just like move them around and stuff, and you can actually like have everything that's put together. And so,
sorry, one second. So how I think about it is that it's not like I don't think about it as like putting these together. I think about it as like glue. So it's like how it's like you're basically just gluing all the stuff together. So that just helps me to understand.
Yeah. And so there are other fancier things that Jonathan might go into tomorrow about these about like different ways you can constrain things, and all these you see all these tabs up here. But the main thing you're going to use is just what you get when you immediately click on it, which is just called mate. And then out of mate, there are two different kinds. There is, I guess it's just also called mate here, but then there's also a flush option. And so although they basically do a really similar thing, as you can see by these pictures here, what mate does is you get to choose a face, and then you choose the other face that you want to click on. And okay, I think the man noise, I don't know if you guys can hear that, but but yeah. And so I have these two faces, and you can see Autodesk automatically just basically, as Jonathan called it, glued them together. And so what that does is like whatever two faces you click on, it puts them on the same plane, and like it faces these planes together. And so this is the offset, but you just want 0 inches because we're directly putting them together. And you click apply, and then now I'm going to do a flush tool, and this basically it chooses the two faces, the first face and the second face, but instead of trying to put them together, it makes them sort of parallel and on the same plane instead of facing each other. And so those are the main two things you use. And yeah. And so now we have a situation where I want to put this piece like in the middle, right? And so right now, as you can see, you can just kind of slide it. It's not actually like, I could do this, but you know, obviously when you put other stuff on, it can get really weird when you can just have it slide around. And so you always want to make sure all of your parts are constrained, because some, like, although it's obvious for this part, sometimes you'll have parts that like are really weird, and you want to make, you can try to like move them around to make sure they're constrained in the way that you want them to. And so right now I've constrained this part to this plane, but the problem is I want to have it put in the middle. And obviously if I just tried to like have this flush to this plane, then it would just be all the way over here. And so you have to think about, at least something I would do is I would create an offset. And so as you can see, there was an offset tool here and this. So this, I would have flush if it has 0 inches. But you have to think about the offset, that's part of it. So this tube, we know, is an inch thick, if you remember. And I made them, and all of them are 10 inches long. And so that means, and this is kind of like doing math in my head. So like, if you like don't follow this, let me know. But so basically, this tube is an inch thick, and this whole tube is 10 inches. Therefore, there's like 9 inches of tube that's like not within this section, if that makes any sense. So if we make half of that, so if we make the offset of 4.5 inches, okay, so as you can see, sometimes it'll make it go in the opposite direction. When it does that, you can just add a negative, and it makes it correct. And so what I did is basically between this face and this face, there's 4.5 inches here, which means there are also 4.5 inches of face on this side, and plus this 1 inch, that's the whole 10 inches. Therefore, it's right in the middle of all the parts, basically. Does that make sense? For everyone? I don't know. I'm gonna assume that's yes. Obviously, just like say something. Okay, and so I'm just gonna do the same thing over here really quickly. Oh yeah, and so over here, let's say, as you can saw there, I like misclicked over here for my first one. I wanted to get this top part and this one, but I misclicked over here. And so you can either just cancel out and go back and do it, or you can have here is a selection of the faces. And so this one is your first selection, the second one is your second selection. And when it's white, it means you've already selected it. And if it's kind of red like this, it means it's still a selection that you have to make. And so I'm just going to click this again to reset it, and then go over here and actually do what I want. Also, you don't have to leave inches here because the assembly itself is already in inches, it knows to make it work like inches. You don't have to have inches there every time. And so yes, this is the base of our bike stand, all constrained together. As you can see, I can't move it or anything. And if we didn't ground this tube right here, as you can see, then you would actually still be able to kind of move this around in the world, but grounding it, make sure everything is put in the same place and is stuck together. And so yeah, now I'm gonna make sure I gotta save this. I'll just call it full CAD class bike. Oh my gosh, I don't know. Bike one, sure. They're gonna be making another bike stand. Oh, sure, I'll bike stand. I'll do it later. Anyway, and so yeah, now I've saved the assembly to make sure everything's good, and yeah, now we're done with that part. And so if we go back to this, although you can't really see it here, now we're gonna make these parts. Okay, and so this part, we're gonna make these, although it's circular tubes, and if you look back at the video, they also use circular tubes, we're gonna use square tubes instead for this part. And so what you have to be careful is in the video, as you saw, he had 2 tubes, and then the outer diameter, okay, so I'm just gonna explain in terms real fast. And so I guess actually, okay. So like for circles, there's an ID and an OD, or like inner diameter and outer diameter. And the inner diameter is just the diameter of like the hole, and the outer diameter is the diameter of the actual like edge of it. And so what he had is he made sure that the outer diameter of the smaller tube is opposed to the inner diameter tube's inner diameter. Like, sorry, I mean the outer tube's inner diameter. So basically that makes it so like slides really well, and it doesn't like wobble around when you put them on top of each other and stuff like that. And so in the real world, you can't just have them like perfectly equal, because there are all these tolerances and everything. And you also might put things like lubricant or something like that between the tubes to like make sure they slide well. And so I'm going to put a very small difference between the tubes, but besides that, everything should be the same idea. John, do you want me to leave that tolerance? Is that good?
Hmm?
Like, do you want to have that tolerance in between, or should I just like?
Oh yeah,
just
make it like
okay.
50 thousandths of an inch.
50 thousandths. Okay, sure. So I'm gonna go back. Yeah. Actually, no, I don't want to place. Go back to file, and so file is just like universal place to go back to. Even if you want to convert things, export files, save the file, open a file that you already have, or create a new file. So I'm create a new file, standard, same thing. And so this part, I'm just gonna make the same sort of like basically a really similar part to what we just did for the base, just a 1x1, and that way. So I'll show you a second. So, and as you can see in this bike stand, that will allow it to line up pretty well. All right, here, let me see if I can turn it. So like it'll line up pretty well with the same dimensions of the tube, so that, here, this is better. And so that like when it falls down and we have brackets on the sides, it'll cleanly sort of like fall in line with the actual base of the tube. And although obviously it depends on like if you can find that kind of tube when you're trying to make a robot or whatever you're trying to make, or a bike stand, but for now you can just have it's nicer if you have this like the most outer tube lined up nicely with this, with all the outer edges. Offset the same. Oh gosh. Okay. And then that didn't make the dimension 0.1 inches. Finish the sketch. Extrude it. Find the face. Make it. I don't know. How high do you want to make it, Jonathan?
Should be like 12.
Well, sure. Okay. Not 122. 12. So I just make it 12 inches for now, and then. So, okay, yeah, that'll work. And so I guess something that you want to think about, again, is going back to whenever you're making parts like this, especially parts that are moving, you still have to think about all the holes you have to make to constrain this. And so I was thinking ahead, and I was like, okay, so we're going to have this board here to hold the bike stand, and that's going to have some brackets down here like this. We might do this a little bit differently, but yeah, I'll have brackets like this to support the board. And so when it's like this, that means that there are going to have to be bolts going through this tube so that it can, well, I guess, Jonathan, do you want to have them screw in, or are they going to like go all the way through?
Yeah, probably all the way through, so you don't have to thread the bolt into the outer tube.
Yeah, okay. So we're just going to have clearance holes that are going to have to go through here, and then the bolt's going to go all the way through this piece. But what that means, but the problem with that is that we also have this inner tube right here that this tube has to slide in, right? And we really don't want the inner tube to be hitting these bolts every time it goes down, because that's really bad. And that'll also limit the bike stand's like movement, if that makes any sense. And so we have to make sure that these bolts don't interfere with the length of this tube. And to do that, we basically just have an extra length. So we chose 12 inches. That just means we have to make this inner tube a little bit less so that we have room to put all the bolts in up here. And as you can see, we'll also, yes, we will have brackets here. So like when it's all the way down, we will have brackets here to rest it. So there will already be a difference. But just to be safe, I'm going to add a little bit of tubing to make sure that all these bolts are clear. So that's just something to think about as well. So I'm going to go back, change the material to steel, cast steel, right? Yeah. Cool. Save it. I don't even know. Outer actuating. Okay. And then I'm going to create new part standard. Oh yeah. And then go here. And so for this part, this is going to be the inner tube. So we have to make sure that this plane is smaller than this outer tube. And so also a tool that's really useful is, so like, let's say, oh, I made this part like yesterday, or like I just don't remember any of the dimensions of it. You can click tools or inspect. They have the same tool. And so you can click tools, and there's this measure tool, and it basically just acts as a ruler in CAD. That's pretty much it. And so you can click this line right here, and it gives me the length of this tube. I can also click this face, and it'll even give me the length of it, the perimeter of the whole sketch, and the area. And so it has some advanced things you can do for you, but it's basically just a tool that like tells you the measurements of any lines or faces that you have. And so, but what I'm going to do is I want to find out this distance right here. And so that means that I have to make this tube less than 0.8 inches. And so John said that we're going to have a 0.05, I think, tolerance between the edges. So that means 0.1. Wait, is it too much? That sounds like a lot. I think that's too much. I'm going to say, I know it's 0.05. Yeah, that's 0.005. And so this is 0.8 inches. So if we were to make it exactly flush to it, oh my God. Actually, that works. I'm just done. Okay, so if we're making exactly flush to it, you could have 0.8 inches. But also something you can do in Autodesk, and I say that a lot, you can, so you have the dimension that you want to make. And then what you can do is you can even have Autodesk do math sort of inside this. And although it can look kind of gross if you like have too much stuff there, but I know that I'm going to want a 0.005 tolerance on this. And as you can see, so like when it's red like that, that means like something's wrong with what you're putting in, and it's not going to let you actually define that dimension. And so what I have here is, yeah, that's just 0.795, but it, so like it kind of just helps. It's just like easier to put in. Oh, I have a 0.8 tube, and I want it to have a 0.005 tolerance. So then that's just going to make that, and then it'll also just turn into an actual number after you do that. Oh, actually, well, I lied. But yeah, they'll have that actual number displayed here, but if you click on it, it'll have all the same math that you did. And so also something you can do, oh my gosh, okay, is, so like, as you can see, this dimension is called D0. And you may not necessarily use this a lot, but I know that I'm always going to want this to just have, like, to be a square and have the same dimensions on both sides here. And so, oh my gosh. And so what I can do is I can reference this as D0. And what that does is it says, okay, this is D1, but D1 is just going to be equal to this D0 dimension. I think you can also actually, yeah, you can also just click on it instead of typing in D0 and figuring it out. And yeah, and so now you have a function here, which means it's referencing this line. So let's say I made this like 0.6, I'll make it 0.6. And so that's really helpful sometimes when you're making things that you know will always be the same dimension, or like, let's say you have like a bunch of holes that you're making and you want them all to always be the same screw, but you're like, oh shoot, I want to actually make this, use a different bolt, and you have to make a bigger hole. So you can just change one of the holes and it'll make all the holes the same. Oh gosh, can't do that yet, I forgot. So yeah, anyway, also here is the main Autodesk thing, as you can see. So here, there's a lot of stuff going on, and that Jonathan will talk about more probably within assemblies. But here, just for a part, you're probably not going to have that much stuff over here, except, so you're going to have, right now it just has this base sketch. You know, I right click on it, it gives me a bunch of options I can have. I can make it invisible, which can be helpful sometimes whenever you're trying to like look at other parts. But so I have this sketch here, and you can also just edit this sketch. That's one of the best ways you can do to just get back to any sketch. And so I'm just gonna make the offset of this same as the other one, 0.1, and finish that, extrude it, and I don't even know, like 11. We'll go with 11. 11 inches. So 11 inches is less than the 12 inches I made, so that we have an inch of space over here for the bolts. And so the right click thing makes more sense here, because now when I have this extrusion, I'm like, oh shoot, I actually want to change that sketch again, but the sketch is gone. No, it's not. You can just right click it in the edit sketches right here, or you can edit the feature. So if I click edit sketch, bring you back to the sketch. Well, now it's also here. But if you click edit feature, bring you back to this menu, and you're just editing this feature, you get like 100, but no. So yeah. Then I'm gonna change the material again. Cast steel, and yes, cool. So this is the inner tube, and yeah. Tomorrow, Jonathan, I think, is going to be assembling most of the stuff that I make, but for now, I'm just gonna make all the parts for us and show you how to use the main tools.
And you can just you can put the inner and outer tubes on there, and then I'll just do all the extra stuff.
Sure. Okay. Inner actuating tube, outer actuating tube. So yeah, these constraints will probably change when we add, might change when we add the brackets and stuff, but for now, I'm just gonna put them in the assembly so we can kind of see what's going on. And so this tube, I'm gonna rotate it. So it just has this axis right here, the Y, X, and Z, and it has these options to just rotate it 90 degrees. And I need this face up, and I can see that this axis is pointing this way. And so if I rotate the X 90 degrees, which means it'll like bring it around. Okay, it's really hard to show 2D, but it'll just rotate it like around this like X like that. So if I do that, yeah, it'll just turn it like that and just keep moving it around the X axis. And so, okay. So this is kind of wacky how I might constrain this, because it's like not evenly an inch. It's okay. Use the measuring tools. It's 0.795. Okay, actually I'm going to calculate for this. So this tube is 1 inch, and this is 0.795, and that's 0.205 divided by 2. And then what I can do, actually, so first I'm going to just go ahead and constrain this onto those two faces like that. And then now what I was calculating is I've got this distance, like this line right here, this distance, and then I know this is an inch, and so I subtracted that. And so because this is the inner tube, when I have it like this, it's not the same size. And so I want it in the middle. So what I basically did is I took this distance by subtracting the 1 and divided it by 2. And so I put that 0.1025 into here. Yeah, and nicely centers it on the bar. Then I do the same thing. Okay, so this now totaled from here to here is 12 inches. And this is the 0.795. And I'm going to do the same thing I did before, basically. And so now when I can constrain these two planes here and add the offset of 5.60, 0.25, and it puts it right. Should be in the middle. Yeah, nicely in the middle of both of these pieces. In this one, okay, I think I'm just gonna do this because it's like okay. So I'm not gonna constrain this to this tube because as you remember earlier, instead of actually no, I'm lying. I'm actually gonna do that. But remember, I can't just do a simple constraint from this face to this face because then, like, okay, you can't tell from here, but we had that little tolerance. Oh my god, that's so gross. We had a little tolerance. So basically that made a little hole here, but not on the other side where I'm constraining it. And so I need to add an offset of that tolerance onto here. And that should be the right way. I think so. I think that's right. Yeah, that is right. And so it's not colliding the tube, so I know that's the right direction. I'm just gonna do the same thing. Right. To make it easier, so like, oh gosh. And so sometimes because like here, it's gonna be hard to select like all the faces in here, but because it's not fully constrained, I can just move it out this way a little bit, and then I know, now I can see the faces that I wanna constrain, which are these two. Just add the tolerance.
Wait,
Okay.
I have a question. So in your original, like the difference between the inner and the outer of the two tubes, isn't it 0.05, right?
I don't
The
remember.
offset?
I can check.
So
check.
I think that you should be typing 0.025, right? Instead of, because it would be 0.05 divided by 2.
Okay, so I'm trying to think. And so like when we made the inner tube, remember? Oh yeah, because we only yeah, you're right. Because we only subtracted, yeah. So like what we did is instead of having like an offset of 0.005 on both sides, we just subtracted the whole distance by 0.05. And so what Jonathan's saying is that because we only subtracted one side by 0.05, the total distance of like, okay, it's gonna be kind of hard to explain looking like this, but the difference between, okay, actually I can show you what I'll show you here. So if I take the measuring tool, this distance right here is 0.8, but this distance is 0.795. So like what I was doing before is I had the entire tolerance on one side of 0.005. But what Jonathan reminded me of is that because the whole thing has a tolerance of 0.05, it's actually between one side, it's actually half of that tolerance because the tolerance is divided by both sides. Does that make sense? And so what I'm going to do is, so like when you can click on a part and it'll highlight it over here, any part that you click on. And so I'm going to need to change the constraint of this adder tube. And then if I click on this arrow, it'll show me all the constraints that have to do with this part. And I know both of these are just the tolerances. And so as I showed you, Autodesk will do math or not. Oh, okay. It's because, yeah, hold on. Take out the inches, it'll work. Because it gets confused if you leave that. And then just divide each of these by 2. So now it should be in the center, right, Jonathan? Yeah, Jonathan agrees. Okay, and so we'll fully constrain this to the ground, and Jonathan will show you some other ways to constrain this tomorrow. But for now, I'm just going to leave it like this because now you can see that we have a tube that's sliding up and down on our base. And don't have a whole lot of time left, but so I'm just going to show you this one thing that we'll do tomorrow. So with this bike stand, one of the things you can do is you can sort of create a sketch that sort of resembles like a mechanism like this, especially because of how complex this is when you have this is a constrained distance and this is a constrained distance and you're trying to like make this actuate. What you can do is you can make a sketch that resembles it. So I'm going to open the sketch from here. Oh my gosh, I did not name it well. when I made this sketch. Okay, okay, so this is the lift mechanism sketch. And as you can see, although it's saved as a part, I really just made a sketch here to resemble a thing. So, oh my gosh. Okay, so I added this guy. And so what this is representing is, so this is the thing I made first. And so on my design, it's scaled differently. And so the distance between this is the middle tube and this is one of the base tubes. And that distance was 12 inches. And then I knew that this point where it's going to be supported is 1 inch. And then this is a sketch of the middle tube. And then this resembles the outer tube that's going to be lifted, but I just sketched sort of the point of where it's going to connect. And so what I made is I have this angle is constrained to 160 degrees, and this length of sort of, of this arm. So it's really similar to here. So I made this 160 degrees. I made that length of the arm the same. This part, this distance the same, and this distance the same. And so I made a sketch of that mechanism so that now when it's constrained like this, I can pull down here. Oh my God, it kind of breaks sometimes, but it sort of shows you the mechanism that you can do. And what it kind of does is doing things like this can allow you to see, okay, so like once it's pulled all the way down, how high up is this going to go? And you can kind of play with it to find like optimal distances. And so, for example, I can just change this distance to like 7 inches and this distance to like 5 inches. And so when you make a sketch like this, it allows you to figure out sort of like the distances you can make all the different parts they are using.
Hey, Jacob.
Yes.
So does this sketch, does it actually like affect any of the actual components? Or is it
No.
just like, okay, just
No. Yeah. So yeah, this is just sort of like a model they made before. I didn't make any of the dimensions on the actual bikes and reference this, and I don't think that, at least to my knowledge, I don't think you can reference a certain, like an entire part files like as one of those dimensions to a different file's dimensions. That you kind of just have to sort of copy over, or just like, but so I just made this as sort of a model of what I was doing, and then I went and made all the actual parts here and found, so this is the point, that's the point of this arm, and that's the end of it, and I just made that sketch. So if I open this, okay, so this actually looked kind of weird because I did some weird stuff, but as you can see, it has, oh my gosh. So first what I did is I made this line here, and it has that 160 degrees that I add in the sketch, and then it has the distance that I had and the entire length here. And so doing sketches like that can sort of help like model what's going on before you put everything together. And yeah. And so I think I'm kind of out of time. If you want, I can keep going, but Jonathan, should I just finish?
Yeah, I'll try to finish up on Friday.
Okay, so we're gonna end it here because it's been like, well, it's almost been an hour of straight CAD. And so yeah, so we're just gonna end the lesson here, and Jonathan's gonna pick up basically where I left off tomorrow and finishing up the CAD stand here. And so far we've just made the base and the inner tubes and how they actuate.
And usually at this point in FRC, we would like eat a bunch of snacks, but since we can't, now we're just gonna end the Zoom.
Yeah.
Like you need a break after like this long of CAD.
Mm-hmm.
So see you on Friday at 1:30.